Right, Bismillah. Right, okay. Okay folks, welcome back after you had your break. I'm just doing my class here, GCSE class. So I've just done the examination paper and the examination conditions. We've had a 15-minute break and now we're going to do the full recap. And hopefully we'll finish before 10. Okay folks, this is the paper that we're doing today. It's Edexcel GCSE paper, Mathematics A. Paper 2 is the calculator paper. That doesn't mean it's easier, it just means you use a calculator. Okay, it's the 1MAO syllabus, /2H is the second paper. This is the higher tier, and this is the June paper last year, 2013. Okay, so I think you're supposed to do the last one. Sorry, just do myself. Okay, it's quite easy. Right. Okay. Right, question number 1. Here is a cuboid. Let's see if we can make this. That's what you do. Make it bigger and smaller when you need to. Okay, Smear's going to be my controller of the board. Let's make it a little bit bigger. Take it up, please. That's it, lovely. So here's a cuboid. The cuboid is, this is the dimension, 6 by 1.5 by 1.5. Work out the total surface area of the cuboid. So just check this working. Now, surface area. Sounds similar to area, but surface area is talking about every single face in the shape. Now, in this particular shape here, if you call this face is 1, top 1, 2, and the side 1, 3. Now, we can only see 3 faces of this cuboid in this particular view. How many faces are there in the cuboid? 6. So the 3 that you can see, and there's an equivalent number on these ones you can't see. So there's a front and there's a back part. There's this side and there's the other side and there's the top and then there's the bottom. So the shape is symmetrical about these 3 shapes. So if we work out the area of part 1 and the area of part 2 and the area of part 3 and we add them all up, what should we do then? We should double it to work out the area of the whole lot. Okay folks? So 6, 1.5, put some measurements on there. This is also 6. That's 1.5 here folks. Look at it carefully. That's 1.5, 1.5. Okay, right. So the idea, what is our idea? So the surface area is equal to the area of 1 plus the area of 2 plus the area of 3, and all of that is going to be multiplied by 2. Okay, you happy with that, Zishan? So let's look at the area of the first part here. At the moment, I think this diagram is a bit cluttered with all this stuff. Let's take some of this stuff off. Let's go back to what it was before. So A1, A2, A3, I think it's getting a bit too cluttered with all the numbers and arrows. Now, area of A1. So this is the rectangle shape of the first face. So it's length times by width. And the width is 1.5. So it's length times by width, plus length times by width, plus length times by width, times by 2. Right. Okay, so Ifra, the length of the first one was 6. Yeah. Time by 1.5 is the height which comes from there, 1.5, 1.5, 1.5. Okay, and then we're going to do the area of second face, the top one. So this one is, what's this length here? Umar? 6, and the side one is 1.5. Okay, now the side piece over here remains. We have 1.5 by 1.5. And all of this is going to be multiplied, added together, and then multiplied by 2. Right, this is a calculator paper, so folks, can you jump on the calculators, please? I mean, I don't mean literally jump on the calculators, but use calculators. So we've got 2 times by brackets, 6 times by 1.5, add 6 times by, 6 times by 1.5, add 1.5 times by 1.5, close brackets. Okay, what do we get?
22.5.
Okay. Okay, did you put the 2 on the outside?
Yeah.
40.5.
40.5, I got. Okay, what you got, Khalid? Young man? You doing it? The calculator, come on, do it. Okay, put the calculator, come on. Put the calculator. I want everybody in the class to put this in the calculation, please. Done? Yes, we all got 40.5. Okay, so the answer to that So the surface area is equal to 40.5 centimeters squared, and that is the total surface area of the cuboid. Quick recap while you guys finish this calculation. Area of the first face, area of the second and third face, add them all up and double it, because whatever we can see there's another one behind it in the 3D view. Okay, are we happy with that question, folks? So is there any more to this question?
No, sir.
Okay, let's go to the next question. You gotta watch out for that little blip, the video stops recording. Okay. Right. Here is a list of ingredients for making 18 mince pies. And we need to work out how to make 45. So it starts at 18 and becomes 45. So we've increased it by a certain number, yes? For this, we can work it out using scale factor technique. It's a simple way of doing it. Okay? So we say 18 has been enlarged by a certain number, the scale factor, and that gave us an answer of 45. Now, for example, if they give you the ingredients for 18, for example, ingredients for 18 mince pies, this is the ingredients for 18, you want to now make 45, so it's going to be, say for example, that 45 was 36. So you can say, oh sir, yeah, that's easy, because 18 times by 2 is 36. So if we double the number of people, we've doubled the ingredients. So that's what we're trying to work out. What is that multiplier? It's obviously not 2. Yeah? It's 2 and something.
Yeah.
So 18 times by a number gives us 45. This is our multiplier, our scale factor. How many times more people we can have than 18?
2.5.
So what we do here, opposite, if you want to work out scale factor, opposite times by 18 is? Divide by 18. So the scale factor is equal to? 2.5. That's one way of looking at it. Another way is by doing it like this. It's called the unitary method. So what we can do, the second way is this. We want to go from 18 to 45. We divide by 18 and then time by 45. So folks, use whichever method you find easy. I'm not saying you use this method. You can use this is the method traditionally taught in schools. Divide it by itself and time by 45. That will take this to that. Okay, it still gives us 2.5. Okay, we're happy with the 2.5?
Yeah.
Now what we need to do here, because Elaine has these ingredients, 1 kilogram of butter, 1 kilogram of flour, and 500 grams of sugar, and so on and so on. Does Elaine have enough of each ingredient to make this new extra mixture? So what we need to do now, let's get rid of this for a moment, is it in the way? We need to multiply each of these ingredients by 2.5. So can we please get busy with the calculators? Can we multiply each one? Okay, can I have some assistance on the top two, please? Can you give me the right values, please? Not less.
562.5.
For the top one?
Yeah.
5, 6.
2.5.
Okay, the next one?
875.
875.
Yep.
Yeah.
Okay, I missed one out. 280 grams of minced meat. That will give us 700. So what we need to do now, so we know now if we go from 18 mince pies to 45 mince pies, we've got to increase the ingredients by a factor of 2.5, which we've just done. So this is the new set of ingredients we need. So this is for 45 mince pies. Right, now we've got to check these numbers. So 562.5 against 1 kilo of butter. So do we have enough butter?
No.
Yes, we got more than enough.
Yeah.
Do we have enough? Yeah?
Yeah.
So we need half a kilo, just over half a kilo, but we've got 1 kilo butter, so we've got enough. The flour, we've got 875 grams, but we've got 1 kilo of flour, so we've got enough flour.
Yeah.
We need 250 grams of sugar, and we've got 500 grams of sugar, so we've got enough sugar. We need 700 grams of mince,
Yeah.
but we only have
600.
600, so that's a problem.
No.
Okay, 6 eggs, so we've got enough eggs.
2.5.
Okay. Right, so the answer is going to be, does Elaine have enough?
No.
You must show clearly how you got your answer. The answer is no. Elaine is 100 grams short of minced meat. So Elaine is 100 grams short of mincemeat. Okay, so you have enough butter, enough flour, enough sugar, enough eggs, but we don't have enough mincemeat. Which is now 600 here, and we need 700. Okay, that's done. That's enough working out. Okay, we happy with that, folks?
Yeah.
Right, that's done. Okay. Okay, the graph. Yeah, okay. The scatter graph shows, what this massive is here, shows some information about 10 cars of the same type and make. The graph shows the age, years, and the value of each car. Okay, right, the next rest of the question, okay, it's take back down. Okay, I've got a copy here. Right, the next part of the question says the table shows the age and the value of two of the same type of and make. Okay, and it says here, so the age is 1 year and the value is 8,200, and the age is 3.5. So just pop up a bit, just for temporarily check it up. Okay, so this is the next part of the question, which we can't see all at the same time. So the age is 1 year, the value is 8,200, the age is 3.5, and the value is 5,000. Let's put this information on the table first of all. So take it back up. Okay, right. Now, so let's have a look. We're going to do 1 year and 8,200. So 1 year old, and the value is 8,200. So first of all, let's establish the scale. So 0 to 2,000, so the halfway is 1,000. So 1,000 is how many little squares? So 5 little squares is equal to 1,000. So how much is one little square equal to?
1, 2.
So one little square is worth 200. Okay, Zishan, I'm working on the scale. So we've been told to plot 1 year against 8,200. So I've got to come up or down here. And 8,200 is 8,000 and one more little square. Done. That's one value. That's one I'm just putting down. Okay, the second value we need to plot is 3.5 and 5,000. So 3.5 years. So 1, 2, 3, 4, 5. 3.5 years. And what's the value? £5,000. So £5,000, that's 4,000, and 5,000 is going to be 1, 2, 3, 4, 5. Okay, alright, let's have a look. Okay, just to make sure I get this right, I'm just going to use my ruler. You should really use your ruler as well. Okay. Right. Okay. So here's our 2 points. Okay, did everybody manage to put the points on properly? Yeah? Now, the next part of the question says, the next part of the question says, describe the relationship between the age and the value of the cars. Okay, now, we're not going to be moving the graph up and down because we're going to lose this information here. So we just have to read it and it's right on the board. Now folks, first of all, let's do a line of best fit because we need that anyway for the next part of the question. Now the line of best fit is going to be fit roughly where?
In the middle.
So like an average of that, yes? So it's difficult for me to see on this one here. I've done one earlier. Okay, I think that's round about the number. Okay. Your line of best fit is like an average line between the data, so it's like running through the middle. So try to go through as many points as possible. Okay. Oh, that looks okay. Okay. Now, what can we see from the line of best fit? It's going down. So what's happening here? As the age of the car is increasing, the value of the car is
decreasing.
decreasing. So how could you describe the relationship?
Negative
It's a
correlation.
negative.
Correlation.
Okay, what happens if you write down negative in the exam? Just negative. Will you get any marks for that?
No.
You get 0 mark. You must write negative correlation or, so let's write down the two possible answers we can write down. So what's the first answer? It's a negative correlation is the relationship. That will get you the mark. Okay? Or you can write down
As the age in car
increases, yeah,
the value decreases.
as the car's age increases,
The value of
the value of the car decreases. Both answers are perfectly acceptable in this type of question, but do not just write the word negative, you will get nothing for it. Negative alone doesn't mean anything. It must be negative correlation, or you actually describe the relationship. So as the age is increasing, the price is decreasing, and that's done for the question. Now, the next part of the question says, a car of the same type and make is 2.5 years old. Estimate the value of the car. So 2.5 years old. So let's find 2.5.
Oh, I missed that question now.
I don't know. Really won't be the first one.
6,000.
So here we got 2, 2.5. 1, 2, 3, 4, 5, 2.5 is there. So we need to go up. Okay, now here's the 2.5 years. It hits the straight line right about there. I've seen students do this in exam papers without the line. They must have some magical powers. And they know when to go across. Okay, now, on my graph here, I'm getting approximately, that's 6,000, about 6,200. 6,200 roughly. Okay, 6,200. Now we are allowed a certain amount of, now, depending on the answer, so we are allowed an answer for question number 3 between 5,200 and 6,600. So you got some allowance in your answer. So obviously everybody's going to be in exactly the same place. So as long as you have an answer between 5,200 and 6,600, you're bang on the money, and that's right. Okay, you happy with that question finished? Yeah? So that's the answer for the last part. Okay. Right. Rihanna plays a game. The probability that she will lose the game is 0.32. The probability that she will draw the game is 0.05. Rihanna is going to play the game 200 times. Work out estimate for the number of times Rihanna will win the game. Okay. So we have probability of losing plus the probability of drawing plus the probability, which can missed out for the moment and bring the question, probability that you will win. All of that together must give us a total of 1. So if you want to work out this one here, opposite of add probability of losing, opposite add probability of drawing, what do we do? Opposite those is, take them over to the other side. We've got to make PW the subject. So opposite of plus PD is minus PD, opposite of plus PN is minus. So we have PW is equal to 1 minus the probability of losing minus the probability of drawing. Okay, let's put some values in. So you have 1 minus the probability of losing. What's the probability of losing?
0.32.
And the probability of drawing?
0.05.
Okay, so probability of winning, probability of winning. So what that give us?
0.63.
0.63. Excellent. So probability of winning is 0.63. We have to deduce that from the information they gave us. Now, she's going to play the game 200 times. And the probability that she will win is 0.63. So what do we do with those two? So the probability that she wins times by the number of goals that she tries it. Okay? So, probability that she wins is 0.63. Multiply that by 200. Okay, so she's going to win 0.63 at the time. What's that give us an answer of?
126.
So she's expected to win the game 126 times. Done. Ready for the next question, folks? Yeah? Okay, right. Question number 5 is a questionnaire style question. Mason is doing a survey to find out how many magazines people buy. He uses this question on this questionnaire. How many magazines do you buy? 0 to 4, 4 to 8, 8 to 12. Right. Write down 2 things wrong with this. There's possibly more than 2 things, but we can write down at least 2 things. Let's start with Zishan. Give me one.
Is it that the options overlap?
That's right. So the response boxes overlap. So you have overlap in the response boxes. What that means is the number 4 happens twice here. You can put the answer 4 in 2 boxes. Let's make an overlap. So overlap in the response boxes, the values. Okay, the next one, a nice and easy one. It says how many magazines do you buy, and what should be next?
Daily.
So there is no, there's no time frame, there's no time that you're asking the question over. Okay, if you copy this down. Okay, it goes write a better question for Mason to use. What else could we write down? Is there any other for that one? One more. And one more possible answer that you could write. You only need 2, but one more you could write. Non-exhaustive response means you haven't given an answer for more than 12. So that's another mistake.
Yeah, you could do 12 plus.
Yeah, you should do more than 12, or more than 12. Yeah? So there's overlap here. There's no time frame. They haven't asked you to buy over a week, over a day, over a month. And also there's no option for anybody who buys more than 12. Somebody's very sad. Buys more than 12 in a month. Okay, non-exhaustive response. That's missing. So that's 1, 2, and that's a third possible answer. Okay. Because write a better question for Mason to use on his questionnaire to find out how many magazines people buy. So we could ask the question, alright. The same question, I'm just going to modify this one now, okay? Because I want to space the bottom. So how many magazines do you buy in a month? For example, that's the time frame. Yeah? So we could have, for example, 0 to
2. 3
0 to 2.
3 to 5.
You have 3 to 4.
Okay, 3 to 4.
5 to
6.
And the last one could be
7 plus. Or more than 7.
more than 6. Okay? So don't worry about having the same number of response boxes. You should have at least 3. You can have like 4 or 5. So 0 to 2, 3 to 4, 5 to 6, and more than 6. And that will cover us. Okay? Right. Sorry about the squiggles in the videos, folks. We're just recycling the top question. I don't know where you're getting rid of it. So 0 to 2, everything's covered now. So it's exhaustive, covers everything. And you've got a time frame in there as well. And there's no overlap. Okay, the next question, we can't see from here, we have to look at the original paper. Next question says, Mason asks his friends at school to do his questionnaire. This may not be a good sample to use. Give one reason why. That's question C, which is the bottom. If you move it up, you can't see this. Okay, so let's have a look. How do we answer that? So that's question C. Now, if somebody asks his friends, number 1, what's the first word that comes to your mouth begins with B? The sample will be, it'll be a bias sample. He's asking his friends. So one of the possible answers is biased. That's one possible answer. And how many reasons do they want for that? They want only one reason. Let's go through other reasons that we could possibly write down. So biased, another thing is, these friends are going to be all of the same
age.
So his friends are all the same age. And possibly they have the same
gender.
Likes. Yeah, there's also possible they're going to be all his friends are the same gender as well. So that's going to be another thing that's going to affect the results. Possibly same gender. Okay. Possibly, most likely same age, yeah. What else? Another possibility we can have. Okay. his friends might have the same
Interest.
interests, same likes. So in that sense, that's what actually probably causes it to be biased in the first place. Okay, what else can we write down? And what else? What's another one? Another one reason. Okay. Too small a sample. He might only have 2 friends. Write a better information to find out how many. So he might have 2 friends. He might have 3 friends. He might just have 1 friend. He'll be very biased. Yeah. So to do a questioning, you need a nice sample size. So these are, any of these answers will do here. Okay, let's move on to the next question. Okay, let me thank you for that one there. Lovely. Right, let's look at some more example regional questions. Question number 6. Just can you make the text a bit bigger, please, now? A bit more, a little bit more. And then move it across. I'll move that away. Okay, that's lovely. That's much better. Keep it there. Okay, Thankyou Zhong is a company that makes yogurt. A machine fills trays of 20 pots with yogurt. One tray has
20 pots.
Okay, Mr. Ramiz, are we paying attention?
Yeah.
So one tray is equivalent to 20 pots. Okay? In 1 hour, the machine fills a total of 15,000 pots. So 1 hour is equivalent to 15,000 pots. Work out how many seconds the machine takes to fill each tray of 20. So not each pot, obviously we need to work that out first. Each tray. So what we do first of all, Ardaba, we change the 1 hour into seconds, yeah? So we're going to do minutes then seconds, yeah? So in 1 hour, how many minutes do we have?
16.
And how many seconds do we have in each of those minutes?
16.
60. So 60 times by 60 will give us
3,600.
So it takes 3,600 seconds to fill how many pots? 15,000 pots. Okay, now we need to work out how long it takes to fill 1 pot. So we need to go from 15,000 down to 1 pot. How do we get from 15,000 down to 1? What do? We divide it by
15,000.
15,000 divided by itself gives you 1, the unitary method. So we're going to work out 1 pot. So what we do on the right hand side, we must do on the
left.
So divided by 15,000 as well. So folks, you've all got the calculators out. 3,006.
0.24.
Okay, can somebody else confirm that out for me, please?
Yeah.
Okay, yes, Rataba, anybody else? Okay, I'm going to try as well to make sure that you guys are not giving me wrong numbers like you did last week.
Alright.
That was fun. Okay, so what do we have? 0.24, lovely. So each pot is 0.24. How many pots make 1 tray?
20.
There's 20 pots in a tray. The question is not about how long it takes to do 1 pot, how long it takes to do the tray. So we have to do 0.24 times by
20.
So 20 pots. So 0.24 times by 20 is?
0.24.
Did that be nice?
Times 20. 4.8.
That's our grand answer. So to fill 1 tray, it will take 4.8 seconds. That question is done. Okay, is that making sense? Okay, keep an eye on the video, please. Make sure we don't lose. Lovely inside another bit of the video. Make sure we don't lose something. Okay. This is not your traditional ratio type question, but let's see how we get on with this question here. Colin, Dave and Emma share some money. Colin gets 3/10 of the money. Emma and Dave share the rest of the money in the ratio 3:2. What is Dave's share of the money? And the question on most of your minds is, they didn't tell us how much money there is. They didn't, did they? But they told you what fraction of money. That's the difference in this style of question compared to the regular ones. So, now, how many tenths were they all together? 10 tenths. In the full question there's 10 tenths, which is 1 whole. So if you want to work out how much is left over, so we start with 1 whole, or we start with 10 tenths, and we take away all the given column. So Umar, what's 10 tenths? Take away 3 tenths.
7 tenths.
7 tenths. So 7 tenths of the money is left over to be shared between Emma and Dave in the ratio of Emma and Dave. You didn't miss it. Okay, so we have 3. So what do we do? The ratio first of all?
Add it.
Add it. So 3 and 2 will give us 5. Okay, so we got 5 parts. Okay. Now we have to now get this, the remaining bit of the money. So we have 7 tenths of the money, and we have to divide it by 5. So 7 tenths divided by 5 is, so the first part is add of the ratio, the second part is divide. So 7 tenths divided by 5 is
0.14.
0.14. Okay. Right. Okay, 0.14. Now, he says, what is Dave's share? So this is Emma's share, and this is Dave's share. Okay, what's Dave's share, Ramiz? Dave's share is 2 parts, and this is 1 part. So what do we do to it?
Times it by 2.
Add, divide, times. 0.14 times by 2 will give us
0.28.
0.28. Okay, so the question says here, what is Dave's share of the money? So we say Dave's now they gave the question originally in fraction. Should we give back in fraction?
Yep.
So it's going to be 28 hundredths, which we could cancel down to
7/25.
okay. Or we could say 28 of 100, which is nicely. So those are the 2 possible answers. The idea that we're going to be using here to work out the area of the playground, we're going to work out the area of the playground plus the corner that's been cut off. Okay, so the area of the playground plus the corner has been cut off, and then we're going to minus that corner. Okay, so the area of the whole lot minus the red bit that we will cut off from the question, and that will give us the area of the playground. That's one way of doing the question. So, this here is my idea. Now the length and the width of the rectangle, so the length is 80 and the width is 60. So 80 times by 60. Now, the triangle over here, this is 40, the top is 80, 80 take away 40 will give us 40. So this part here is 40, this is 60, 60 minus 30 will give us 30. So the base is 40 times by the height, 40 times by 30 divided by 2. Now, let's start working this out. So 8 times by 6 I'll give you 48, add the 2 zeros. 40 times by 30, that will give you 4 times by 3 is 12. 12 add 2 zeros will give you 1200. 1200 divided by 2 is
600.
Okay, 600. Right, are we happy with that so far?
Yeah.
So 4,800 minus 600 will give you how much?
4,200.
200 meters squared. Okay. Now that's how much meters squared you want. How much is cost per meter?
£2.56.
256. This is the area. So the cost is going to be 4,200 times by £2.56, and that gives us an answer on the calculator as what it gives us.
10752.
Yeah.
That sounds good to me. 10752. So that's the cost.
Oh,
Oh, beautiful.
That's the whole question.
Okay, can you take it up, please? Okay, here you go. Right, diagram not accurately drawn. Now, this particular comment means don't get your protractor out and start measuring the angle. Students do that all the time. Okay, when I'm vigilating some exams, see students, the protractor, oh yes, no, no. The other ones start guessing that it's 45, for example. We'll soon find out what it is. Right, okay. Let's have a look at this question. We have our parallel lines here. We have a line going across the parallel line, and we have another line over here. Now, what happens when you have parallel lines? We get alternate angles and corresponding angles. Now, in order to work out x, what does x correspond with?
B.
So this angle here is the same as?
That, yeah.
Okay, by the way, the angles, I mean, to talk about this angle, we're talking about angle A, B, Q. That's the angle we're talking about. Okay, because angle B could be this one, that one could be this one. So that's very specific now. We're being specific by lettering to describe the angle. I mean, it starts at A, goes to B to Q, so it's that angle there. So what's the first thing that we can say? We can say angle ABQ is equal to x. Why is it equal to x? What's the rule that we just said? Corresponding angles are, and the key word is equal. So you got all that. You can't just write down corresponding or corresponding angles. You've got to give the full proper statement. Okay, so you're giving a mathematical proof here, you need to give the full statement. So this angle here is equal to that angle because they're corresponding, they're equal. Now, how do you work at that angle? What's the rule? How do you work at that angle then? Go on.
You got 90 plus 35.
Yeah.
And then you minus that.
And add that.
You get the answer. And
Yeah.
then you minus
Good.
that.
Okay, now let's look at this triangle here. This triangle, which triangle are we looking at? Now here's another, let's look at this triangle here. Right. What is the angle sum of that triangle? So angle sum of triangle ABQ is equal to what?
180.
180. Okay, so this triangle has 180. Therefore, 35 degrees, add angle ABQ, add this up here is 90. Plus 90, okay, we're out of space, is equal to
180.
180. So let's do some rearrangement here. Now, we've got to work out this angle here. So plus 90 plus 35. So what do we do, Omar? We grab them and take them. So opposite of plus 90 is?
Minus.
And opposite of plus 35 is?
Minus.
So we got 180 minus 35 minus 90 is equal to angle ABQ. So the answer to that is?
55.
55. Angle ABQ. Now, if we know that's 55, what's that going to be then?
55.
55. Angle ABQ is equal to angle X is equal to 55 degrees. Done. So we now use mathematical proof, mathematical reasoning to explain it. So first of all, we've connected this angle with that angle, made a mathematical reasoning, corresponding angles equal. And then we said this triangle here has a angle from a 180. So then we can work out the missing angle by rearranging it, making a statement, rearranging it. And then once we got that one, we just said this is equal to this one because it's 55. I'm just here repeating what was there. Done. Yeah. Okay. I said okay, thank you. Okay, question number 10. The equation x cubed plus 2x equals 110 has a solution between 4 and 5. Okay. Okay, folks. Okay, it's between 4 and 5. Copy the table now, please, folks. Right. Now, we need to put the values into the calculator. So x cubed is 4 cubed. Add 2 times by x, which is 2 times by 4. Okay. So as we see it there, please folks put it into your calculator. So you have 4 cubed plus 2 times by 4.
72.
72. Right, the next one.
135.
Okay, now is the answer more closer to the 5 or more closer to the 4?
4. No.
5.
Or 110. So we're going to start our decimal numbers, the one decimal place numbers. We'll start halfway.
Yeah.
4.5.
4.5. So now we need to do 4.5 cubed plus 2 times by 4.5. Okay, folks, quickly give me an answer that, please.
100.125.
100 point.
125.
Okay, can everybody else please check the 100 point?
125.
So we're getting close already. We're getting close to the 110. Okay, let's try 4.6 now. So you do 4.6 cubed plus 2 times by 4.6.
106.536.
106, okay, good. Okay, next we just try 4.7. So 4.7 cubed. Those of you who haven't done the calculation yet, I'm getting an answer from one person. Yeah, can you try as well, please? Rather than just waiting for the answers to come to you. Okay, let's have somebody else. Okay, let's have Ramita, have you done the calculation? Come on the calculator. Some of my students are waiting for Eid to come again.
113.223.
Yeah, that's good. So that gives us 100 and
13.223.
now, there's no point in trying anymore because that was below and that one's above. So it's going to be, we have to find out now between these two, which one's the closest. So we're going to look at these two, see which one of these two values is the closest to 110. Now how do we do that?
4 points.
It's minus it from 110. This number, take away 110. This number, take away 110. Off you go, folks. We're going to see how close they are. If you want to find out how close the two numbers are, which are either side of it, which one's the closest? What's the first one?
The first one is 3.464. It's minus.
Yeah, minus 3.464. The minus only indicates that if the number is below it. Okay? So that's how much it is below the 110. The next one, 113.2, that should be an easier one.
3.223.
3.223. Okay. Right. So the answer that we have, okay folks, can you check those numbers please? 106.536.
Yeah, that's right.
And the next one is 113.223.
Yeah.
Okay, right, let's...
Yeah.
Let me check myself. 106. Yeah, 0.536 minus 110. Okay, right. Now, that's okay. So which one of these is closest? This one is 3.4 below the number, and that one's 3.2 above the number. Which one's the closest distance? Closest away. 3.2. Yeah? 3.2 is the closest, isn't it? Yeah, and it's above it. It's 3.2 above the number, which is closer than being 3.4 below the number. So this is the closest one. So that indicates that x is equal to 4.7 to one decimal place.
So you
Okay, 4.7. Okay, so you look at these two numbers, see which one is the closest to the 110. This is 3.2 away above the number, That's minus 3.4 below the numbers, that's further away. That's closer.
So I did you get minus one?
What done there? Those two numbers are minus from the original. See how far it is from that?
How did you get 4.7? Did you minus that?
4.7, basically what we said here was that this is the closest one to 110. That corresponds to 4.7. That's what I got, 4.7. That's right. Okay, next question please. Okay, so XYZ is a right angle triangle. Question number 11. It says that calculate the length of XZ, which is the hypotenuse of this right angle triangle. Give your answer, connect it to 3 given figures. One for me as well, please. Right, okay, first of all, let's have Umar. What type of triangle is this? I just mentioned earlier. It is a right angle triangle. If you want to work out the hypotenuse, which is here, what rule do we use for working out the hypotenuse of a right angle triangle? We use Pythagoras theorem. Pythagoras theorem is, so the hypotenuse is always the A, is A, and this is, we call this one B and C. Okay? As long as we label the hypotenuse A, B and C can be labeled in any order, it doesn't matter. So what was the rule again? Umar mentioned the rule is A squared is equal to B squared plus C squared. Folks, don't get hooked up to this particular formula. There's lots of different variations. Some have A squared plus B squared equals C squared, but the C in that case is the hypotenuse. As long as you know that the hypotenuse is A in this formula, then this formula is correct for this question. Okay? Yes, sir. So we need to work out the hypotenuse A, which is the length XZ. Now, Mr. Ramiz, I want to work out the A value, but they've given me the formula A squared. What do we do with the squared?
Square root.
Take the squared over the other side, becomes A is equal to B squared plus C squared square rooted. Okay, we just said here that the A is equal to the length XZ. Now what's the B value? Is 1.35. What's the C value? 3.25. So B squared plus C squared, and then? Okay folks, right, can you give me a nice number for that please on the calculators? Put the square root in first, and then put these values in your cash calculators.
Do you want it in decimal?
Yeah, give me a decimal please to 2 decimal places.
4.28.
Okay. Alright, let me have a go at that question. Alright, we have square root of 1.3. Has everybody else worked out? Just got the same person do the questions as anybody else?
3.5.
1.35 squared.
3.5.
3.25 squared. 3.519.
Yeah, do that 2.5.
Okay, how do you do that in calculator? Check your calculation.
How do you make the screen dark?
Check how you put it in. So the answer is 3.519. Let's just write it down for the moment. Now, instead of giving correct to 3 significant figures,
I got 2.5.
it is actually, this is the right answer, folks. 1, 2, 3 significant figures. This is the last digit. This is the decider. If the decider is 5 or more, you add 1. So the answer becomes 3 point, and you stop there at the last digit. You don't carry anymore. That's the answer. Done? Ready to move to the next question? Oh. Okay, right. So you can make the bit bigger and then just move them up. That's like, ooh, that's beautiful. Yes, okay, solve 3x minus 2 equals x plus 7. This is called a double-sided linear equation. Come on, we ready for that one? Yeah. This x here is being imprisoned in the brackets. We need to multiply it out. We've got x here and there. So we need to release this x first. So, Rameez, what do we do with this one first?
Times it.
Times it. 3 times by x is?
3x.
Okay, good. 3 times by minus 2 is?
Minus 6.
Okay, that's lovely. Now the x has been released from the brackets, we can deal with it. Now the rule for dealing with this linear equation, x is on both sides, is that we start with the smaller smaller x value, and then you move that towards the large x value. As that goes to the left, the number on the left must go to the
Right.
So what we're doing, trying to do here is get the letters on one side and the numbers on the other side. So we now have 3x, which is already here. Opposite of plus x is
Minus 6.
okay. Plus 7 is already here, and the opposite of minus 6 is
Minus
plus
6.
6. Okay. Remember, when we change side, we change sign. It was minus, it's now plus. It was plus, it's now minus. So you're rewriting here. Okay. If Ravi, okay? Not confused, Ravi? So 3x minus x will give us
2x.
okay. 7 plus 6 will give us
13.
okay. This is the part where students are freaking out. Oh no, it's not going to go in exactly. Doesn't matter. So opposite time by 2 is
5 by 2.
that's one way of doing it. So x is equal to 13 divided by 2 is 6.5.
So, but how
One.
do you check the answer? Like,
Just put it back in.
How you check? Put it in there. 6.5 minus 2 times by 3. Does it give you? Check it out. Okay, 6.5. You're happy to move on now?
yeah.
Okay, let's look at the next question. On the paper. Right. Next question, please, Samir. Right, solve 2 minus y over 5 equals 1. Now, what we said before, when we have a denominator in the question, we have to remove the denominator by opposite dividing by 5 is
Times.
time by 5. This is called cross
Multiply.
multiplying. Because we don't want a fraction in the answer. So now we have 2 minus y is equal to 5. Now, for those of you who've got your eyes glued onto the next part, y is, what is y? Y is
Minus
minus. Do we want to work out minus y or do you want to work out y?
y.
Y.
Y. Y.
Just Y.
Yeah. So how do we make this plus y?
Move it.
Move it aside. Normally what we're trying to work out, we don't move it, but in this case we do. So let's move it, let's swap over sides. The minus y needs to be positive. So move that way. Okay, if we don't move it now like this, we'll have to end up dividing by minus 1 to get rid of the minus. Students don't like doing that kind of stuff. Gets them all confused. So let's avoid that kind of situation in the first place. So, we have 2, opposite of plus 5 is?
Divided by 5.
Okay, opposite of plus 5 is minus 5. Okay, so that gives you minus 3 equals y. Okay, so y is equal to minus 3. Let's test it. 2 minus minus 3 is 5. Divide by 5 is 1. It works. Lovely. Okay, so I check with the Kira. How is this? Okay, just stop it as well. Okay, question number 13, folks. Right. We have our graph here. A is the point minus 1, 2, B is the point 75. Find the coordinates of the midpoints of A, B. Okay, now, so we make this graphic bigger, please. Okay, take it up, please. So we first of all, for question number 13a, we've got to work out the midpoints. To work out the midpoints of two coordinates, what we need to do is work out the average of the x and average of the y's. So x and y. So 7, 5 minus 1, 2. 7, 5 minus 1, 2. Okay? So if we work out the average, how do we work out the average? We have to
Minus 1.
you have to add them and then divide it by 2. So 7, okay, add minus 1 will give us, what's 7 add minus 1?
Minus
That will give you 6.
6.
And then we do 5, add 2 is?
7.
Okay. So what we've done now, we've added the x coordinates up, we've added the y coordinates up, and that's given us 6 and 7 as totals. Now we need to half them. So the next calculation, different color. So 6 divided by 2, and then 7 divided by 2. 6 divided by 2 will give us?
3.
So 3 for the x.
And 3.5. And 3.5.
So that's your midpoints. Okay. Next, Right, the next question, let's have a read of the original paper. It's gone at the bottom of the screen. Okay, the next question says, P is the point minus 4, 4, and Q is the point 1, minus 5, find the gradient. Okay, alright, I'm going to do that question over here on this slide. Alright, that's minus 4, 4. P is minus 4, 4, Q is 1, minus 5. Okay, Q is 1, minus 5. Okay, folks, are you ready for this one? Now you've got to work out the gradient. The gradient is called N. It's the difference in the Y values divided by the difference in the X values. What we say is Y2 minus Y1 divided by X2 minus X1. Now let's have a look at Y. Okay, so we'll call this one X1, Y1. This is X2, Y2. So let's pop those into the formula. That's what we get. So the gradient is equal to Y2 minus Y1. So it's going to be minus 5 take away 4. Difference in X values. So X2 minus X1 will be 1 minus 1 take away minus 4. Right. What do we get for that? So minus 5 minus 4 will give us minus 9. 1 minus minus 4 will give us 5. So minus 9 divided by 5 when you calculate it gives us quickly
minus 1.8.
and that is the answer for what I called as question 13B. 13B. So 13B had a different set of coordinates, you had to work out the gradient. That's how you do gradient. That's the formula. Done. Now, a question that you could have asked which nobody did, it doesn't matter which coordinates you call x1 and y1 or x2, y2, it doesn't matter. You get the same answer. Okay, done. Okay, that's nice and big, that's lovely. Okay, have you got all the original question on this, Miriam?
Yeah.
Viv wants to invest £2,000 for 2 years in the same bank. So this question is to do with compound interest. Okay, we have the international bank and the friendly bank. I've never heard of a friendly bank. They're all greedy banks. Okay. At the end of 2 years, Viv wants to have as much money as possible. It's a normal greedy person. Okay. Putting a Bill Gates aside. Which bank should she invest her £2,000 in? So let's have a look. Compound interest means that they add interest onto the previous value. So you're not just looking at the same value each year. So now let's convert these into multipliers. Okay. Now, it gives you 4% interest for the first year. As we said before, the original value, we rate that at what percent? 100%. And then we can increase it by 4%. So 100 at 4 is?
104.
104%. 104% quickly as a decimal is equal to? 1.04. So I'm doing it, explaining each bit individually, but you should be able to do that quickly in the exam. 4% increase means 1.04 as the multiplier. And then the next year is going to be 1% extra. So that's going to be 1% extra. So how much percent is that? 101%. Okay, which as a decimal is 1.01. Are you happy with that, folks? Now, so let's work it out for the international bank. So we start with £2,000. We're going to multiply it by 1.04 for the first year. And 1.01 for the next year. So what we're doing here, we're working out this number. What's 2,000 times by 1? 2,000. So that's what the 1 there for. It maintains the original value. And that 0.04 is really the 4% extra that you can get. That's what that's in there. That's how that's coded, this decimal multiplier. Then after you work that out, the following year, the next year, you're going to be multiplying by 1 again, which will be all this value, and then the 1% extra. So, this is calculator question. Please folks, put in your calculator, give me the answer.
2,100.8.
Okay, 2,100.8, so 2,000
Yep.
times by 1.04 times by 1.01 equals 2100.8.
Yeah.
2100.8. But because this is decimal money, we need to put extra 0 in to make it look right. Because we wouldn't normally use it 0.8. It's 0.8027 pounds and pence. Okay. Now we're going to use the same technique for the next bank. Now 5% extra for the first year. So 5% extra for the first, now we should be able to do quite quickly. 5% means the multiplier is 1.05. And 0.5% is going to be, again, 100%. Add 0.5%. What's 100 at 0.5?
100.5.
100.5%. Okay, what's that as a decimal? Multiplier?
1.00.
Lovely. Thank you. That's your multiplier. So, okay, so we start off with the same £2,000. In the first year, it's going to go up by 5%, which is represented by that. In the next year, all of this money is going to go up by 0.5%. Okay, so let's put that into our calculators. 2,000 times by 1.05 times by 1.005 equals 2110.5. Is that right?
Yeah.
Okay. So, which bank should she invest her £2,000 in? Okay.
Friendly bank. Friendly one.
Okay, so
I don't know.
2110.5 is more than 2100. So what's her name? Is it Viv?
Yeah.
So Viv should invest in the friendly bank. Okay. Question number 15a. Complete the table of values for y is equal to x squared minus 2x. Here's our table of values, and then we'll be drawing the quadratic graph in a bit.
Oh, good.
So let's do the table. Now, minus 2 squared, if you put in the calculator, use the brackets, and then you have a little button on your calculator, which is the little minus one. It looks like this on your calculator, which is up here. Use that one. So minus 2, and then the squared button, and then take away 2 times by the minus 2, put another bracket. So this is how you enter that into the calculator. So okay folks, have a go at that. That's lovely. So on the grid, draw the graph of y equals x squared minus 2x for the values of x minus 2 to 4. Let's just quickly draw out the table of values over here. Quickly, minus 2, minus 1, 0, 1, 2, 3, 4. That was the x. Okay, then we have the y values. And what's the y values? The first one was 8, 3, 0, minus 1, 0, 3 and 8. Is that what we all got, folks? Same values? Yeah? Well, let's plot them now. So, when x is minus 2, y has a value of?
8.
So here's x is minus 2, y has a value of 8, which is here. When x is minus 1, y has a value of 3. X is minus 1, y has a value of 3. So it's 2 is halfway. So it'll be 1, 2.5. Okay, next one. When x is 0, y is 0. When x is 1, y is minus 1. So 1 is minus 1, so come down by 1, 2, 2.5 squares, which is around right there. When x is 2, y is 0. When x is 3, y is 3. Where's 3, folks? There's going to be 1, 2, 3, 4, 5, which is 2. Add another 2.5 squares. 1, 2, 2.5 is to give you 3. Halfway to those 2. Yeah? 1, 2, 3, 4. Okay, now what about 4?
8.
4 is 8. I'll put the stuff in the wrong place, folks. Please tell me. Okay, does that look right?
Yeah.
Is that what you got on yours?
Yeah.
So let's join them up. Blue. Okay, folks, have you got something like that?
Yeah.
Done. That was the question. We plotted it, we worked on the values earlier, then we do this question. Okay, now, without moving the graph, the next part of the graph says solve. Here's the graph exactly this way, don't move it, I'll write on the board. Question C says solve x squared minus 2x minus 2
equals 1.
x squared minus 2x minus 1
Minus 2
minus 2
equals 1.
equals 1. Now, there's our original graph, y equals x squared minus 2x minus 2x. What's the difference here?
Minus 2
And the-
equals 1.
Okay, normally this is equal to,
Y.
and now it's equal to,
1.
okay, let's get rid of this minus 2 because it's to make it look the same. Opposite of minus 2 is,
Add 2.
okay, now let's try to compare this now with back with the original one. In the original one we had, all of this is equal to, so x squared minus 2x was originally equal to y. What's in the place of y now? 3. So what they want you to do now is make the x squared minus 2x, you have to now draw another line on there, and that line is going to be called y equals 3. So where's the line y equals 3? So here's 2, and y equals 3 is, starts there. Alright, let's get the ruler. That's basically what they've done. They've transformed, rather than this graph being normally equal to y, it's, if you rearrange it, it becomes x squared minus 2x is equal to 3. So that's the y value. So we want to find out when this curve is equal to 3. And the best way to do that is to draw a straight line which has the value of 3 and see where it intersects and come straight down. So we need to come down now. We need to come down now. Okay, now what do we get if we come down here? What do we get?
1. Minus 1.
Minus 1. And this side we get?
3.
3.
Yeah.
So the question says solve. So the answer is going to be x is equal to minus 1 and x is equal to 3. Okay folks, are we happy with that? And that's how we solve that kind of question. Okay, ready? Right. Question number 16. S and T are points on the circumference of a circle, center O. PT is a tangent to the circle. Here they are. Tangent. SOP is a straight line. SOP is a straight line. Okay, angle OPT is 32 degrees. OPT, that one is 32 degrees. Work out the size of angle marked X. So what we're trying to work out here in this question is this angle here. Now, give reasons for your answer. First of all, what we need to do is start to identify what we know from the diagram. Diagram not accurately drawn, don't start measuring things please. Okay, don't do the common student mistake. Alright, let's have a look. Now, this is the center of the circle. They tell you that always the center of the circle, yes? And that is on the circumference. What is this distance from O to S? This is called the radius. This is the radius of the circle, yes? And is this part also the radius?
Yeah.
Yeah, because
It's coming from the center.
yeah, so this part I'm going to label in. This part is the same as,
That part.
okay, that's also the radius. So those two are equal lengths. So we can make a statement, line SO is equal to line
OT.
OT equals the radius. That's why they're equal, because the radius of the circle. Now, what happens when a radius meets a tangent? What's the rule for that? So the line, what's this angle here? So this OTP. Okay, what's the angle OTP? 90. Why is it 90? Because when a radius meets a tangent, it always meets that 90. Okay, so we can make our next statement. So we can say angle OTP is equal to 90 degrees. Why is it equal to 90 degrees? Because a radius always meets a tangent at 90 degrees. So we now begin to start filling in the information that we know in the diagram. So this angle is no longer unknown. We know that it's definitely going to be equal to 90. And that will help us in the question. Okay, now, Umar, if you know this is 90 and we know this is 32, can we work at this angle? Because really, in order for us to work at this one, we need to know that one, isn't it? Yeah. From there we can work out these two. And to work out this one, we need to know. So we're just working all the way around. So we know these two radii, we know that's 90. From this two, we can work out this one. From this angle, we can work out that one. And once we know that one, we're done. We're home. Okay, so now, let's look at this angle over here. What's this angle called? It's called TOP. What's the angle TOP? So, we have a triangle here. What is the angle sum of triangle?
180.
Lovely. Angle sum of triangle TOP. Triangle TOP is equal to 180. That's okay, Zishan? So 90 plus 32 plus that will give us 180. So let's write that down next. Therefore 90 plus 32 plus angle TOP is equal to 180. So if we want to work out angle TOP, opposite of adding these two quantities is, take it over and it becomes minus. So angle TOP is equal to 180 degrees minus 90 minus 32. So that will give us an answer of 58 degrees. So we know this is 90, we know this is going to be 58. If this 58, what's this one going to be? What's angle SOT going to be? So angle SOT, this angle here and that angle, what do these two angles add up to?
180.
180. Why is that?
Straight line.
Okay, how to write that down? What would you say? Angles
On a straight line.
add up to 180. That's incorrect. Angles
On a straight line.
at a
Point.
point on a straight line. On a straight line add up to 180. That makes the rule very, very specific. We're doing angles on a straight line at a point on a straight line. So we're not going all the way around and not all the way on a straight line. Now, what was angle TOP?
58.
58. So angle SOT at 58 degrees is equal to 180. So the angle SOT is equal to
120.
120. We need it there, folks. 120. So we know this, we worked out that, from this we worked out this, and now we can work out x. What kind of triangle is triangle SOT? So triangle SOT is an isosceles triangle. That means this angle and this angle are the same. Okay, therefore angle OTS is equal to angle OST. So and they're both equal to x. So this angle is the same as that angle, so they both are going to be x. Now, the last part of the calculation here is, what do all these triangles, what do all these angles add up to?
180.
Okay. So we say that x add 1 to 2 is equal to 180. And the reason for that is angle sum of a triangle is 180. Okay, which triangle? Triangle SOT. Right, now let's look at x. So x at x is?
X squared. 2x.
That's 2x. Let's multiply them. 2x at 1, 2, 2 is equal to 180. So 2x is equal to 180 minus 122. What's 180 minus 122, ladies? That gives us?
58.
And then divide that by 2.
29.
Okay, stop with this now. Okay, question number 17. We're looking at box plots in this question. Some girls did a sponsored swim to raise money for charity. The table shows information about the amount of money the girls raised. So least amount, greatest amount, median amount, lower quartile, upper quartile. Now, on the bottom over here, this is one we have to draw, taking this data over here. The bottom one over here is for the boys, and that's already drawn for us. Now, let's have a look at the structure of a box plot. We have the beginning part of the whisker. That is the lowest value goes there. Then we have the beginning part of the actual box itself. That contains the information of the low quartile. Then we have the line in the middle, or anywhere within the box there, the line going inside the box. That is represented by the median. And then the end of the box is the upper quartile value. And the last part of the whiskers, the end part, is the highest value of data. So that's how, that's the structure of a box plot. So now let's do one for the girls. So we're going to be following this system over here. So this is question part A. On the grid, draw a box plot for the information in the table. So let's do that first. Okay, I'm going to do mine's freehand, but please make sure in the examination you use a ruler. So we have the least amount of money is £10. Okay, that's £10 there. The greatest amount of money is £45. Least greatest is at the end. The highest value is 45, 41, 2, 3, 4, 5. Okay, now let's do the lower quartile next. Lower quartile is represented by the beginning of the box. So lower quartile value is 16. So here's 20. So we're going to go back by 4. So 20, 19, 18, 17, 16. Let's do the upper quartile, which is the end of the box. Upper quartile, end of the box, 42. Okay, so we go across to 40, 41, 42. And last but not least, the median value. So the median value here is 25. So 20, 21, 22, 23, 24, 25. Okay, right. Neatening my diagram a bit, in a bit of neatness. Okay, lovely. So I'm just going to reiterate those values. So the lowest value went over here, the least amount of value. And the greatest value went over here, which is the highest value, 45, right here. The median is the line inside the bar, or the median one. The lower quartile was the beginning of the, and the upper quartile was over here. Okay, so that's the first part of the diagram, first part of the question done. On the grid, draw a box plot. So this is the box plot for the girls. Okay, some boys also the responsible swim, so this is the boys one. Now, question B, which is at the bottom of this screen, is, let's read it out, compare the amount of money the girls raised with the amount of money the boys raised. So the key word here in this question is compare. I'll put a little summary over here. So question B, which is at the bottom of this, says compare, okay, the amount of money raised by the girls and the amount of money raised by the boys. Now in that comparison we need to include a comparison of the median and a comparison of the spread. So then the two key things that the examiner is looking for. Now the median, we need to compare this value with this value. So that's the median of the girls. That's the median of the girls. We were looking at this value here, and this is the median over here for the boys. Okay, so this value here. So we'll be comparing these two values for the first mark. Then we also need to compare the spread. And the spread of the data, when we talk about the spread on a box plot, we're talking about two things here. The interquartile range, which is the difference between this number and this number, this number and this number, or it's the range, which is the largest value minus the smallest value, the largest value minus the smallest value. The range is susceptible to rogue data. For example, if one person got an extremely high value, that will make the range quite big, might be just one person data, whereas the interquartile range is much more of a consistent data, is much more reliable data. Okay, so we are going to today look at the interquartile range as a comparison of spread for these two pieces of data over here. So again, we're going to try to find out here how large the spread is, how consistent the data was. So were a lot of them raising a lot of money, or were they just some of them raising a little bit of money, some of them raising a lot of money, and the same for this one over here. So let's work out the medians are quite, first of all let's look at the median. So the median for the girls was 25. So the median for the girls was 25. Okay, and the median for the boys, okay, I'm going to be looking at my exam paper over here. So I can see the median for the boys represents on the, because the graphs come off the bottom over here. I don't want to move this chart now. It works out to be 32. So this here, this line is at 32. Okay, so we need to make a comment now on that median. So we can say that the boys raised a higher median amount of money, the higher average amount of money than the girls. So that could be our first comment. So point number one. So the boys raised a higher average, and in brackets we're going to write down what we're talking about. The average here we're talking about the median. I.e. median. So what was it? So the boys raised a higher average, the median amount, compared to the girls. Okay, right. Right, sorry about that folks, just a bit of screensaver in there. So the boys raised a higher average amount compared to the girls. How much did the girls raise? £25. Okay, that's our first comparison. Okay, so we're looking about, so if you want to go through that one again, the boys raised a higher average, which is talking about the median amount, which is £32 compared to the girls. So that's the first thing that we say, the boys are more better than the girls in that sense. Now, let's have a look at the second type of comparison, which you look at the spread of the data, we look at the interquartile range. For that we're going to need to do some calculations. So we need to work out 42, the upper quartile here, minus the lower quartile, to work out how big the spread of the data is, this 50% of the data. So, we have 42, and we have to minus a 16. So, we have 2 take away 6, which you can't do, so we borrow. So 12 take away 6 will give us 6, 3 take away 1, okay, that will give us 2. So now, we know that the interquartile range of the girls is equal to 26. That tells you how much is spread out over. Now, let's have a look at the boys' ones. Now, the boys' values for the lower quartile is 18. So I'm reading from my exam paper. And from the exam paper, the upper quartiles are 40. Okay, now, so we've got to work out the difference between these two values, upper quartile for the boys, lower quartile for the boys. So we're doing now 40, take away 18, which will give us 22. Okay, so we've got 22 versus 26. So now we have to make another comment. Let's change colour on our answers over here. So number 2, so at the moment I'm writing all my stuff up here because otherwise I'll have to move everything around and get confused. So number 2, let's fit number 2 in over here. So here we talked about the average in terms of the median. Now we're going to talk about the average in terms of the spread. So we say here now, just have a look, make sure we get our numbers correct. So the girls one was 26 and the boys one was 22. Okay. So we say the boys had a smaller spread compared to the girls. Okay, and they had the interquartile is 26. Okay, what does that mean for us? Okay, therefore the boys were more consistent in raising the money. Okay, so they were more consistent in raising the money for the charity. Okay, and that will be, should be enough for us to get our full 2 marks. So one comment about the median and one comment about the spread, in particular the interquartile range. So a smaller interquartile range is a better, that means they've performed better. Okay, right, bismillah. Okay folks, let's have a look at this next question. We have question number 18. You have to make P the subject of the formula. And there's 4. So let's start again. So we start at P. P is being squared. First action. Times by 3. Second action. Minus 4. Third action. Okay. Now, so the first thing we need to do when you're doing any type of rearranging equation, start at the letter that you've been asked to start at, and then start identifying the first, second, third action that's been done to it. And we've labelled that first, second and third action. Now when we start solving, we're doing it in the reverse order. So we must get the last item with that first. So opposite of minus 4 will give us plus. So now we can rewrite as y add 4 is equal to 3 p squared. Right. What did we say was the, so we moved the last action, which is third action first. Now we're going to move the second action, which is time by 3. So that moves next. So with the time by 3 is divide by 3. So the next bit is going to be y add 4 divided by 3 is equal to p squared. And now we are left with what was the first action, which was the squared. So that moves last. Okay, so opposite of squared is square root. So our final answer is y add 4 divided by 3 and the whole lot square rooted. That will give us an answer of p. Okay, right, let's move on to the next question. I'm going to have to reduce. Here's the next part of the same question. Is factorize y squared minus 16. This is a very special type of question. It's called the difference of two squares, because that's y squared, that's quite obviously a square, so y squared, and 16 is really in disguise 4 squared, so the square number, there's another square number. Now, in these particular type of equations, they have y squared minus 4 squared. We factorize like the following. We copy the y down, copy the minus down, copy the 4 down. Copy y, copy minus, copy 4, leave the squares off at the moment. Repeat the brackets, and this time turn the second minus into a plus. And that's done. Okay. Next one. Factorize 2p squared minus p minus 10. Now in this question here, this is a quadratic equation of the format ax squared plus bx plus c. Okay, in this particular format here, the a value has a value of 2. So when we factorize in the brackets like this, we must have a 2p and a p. Because when we multiply the brackets back out again afterwards, check, 2p times by p will reconstruct the 2p squared. So now let's look at the factors of minus 10. So minus 10 should have minus 1 times by plus 10, plus 1 times by minus 10, minus 2 times by plus 5, or plus 2 times by minus 5. So then all the numbers that will give us an answer of minus 10. So we've got to put them in here, pick one of these and put them in the right order. Once we have the 2p in here, now just a p, the order that we put the numbers in is very important in order for us to reconstruct the minus p, which basically has a coefficient of minus 1. So let's have a look. So 1 and 10, and we're going to start multiplying 1 and 10 in there. We're going to get huge numbers. We won't get one that has a difference of minus 1. So I'm going to skip those for the moment and look at these ones here, concentrate on the bottom two. Now I need to get net negativeness. This will most likely give us a net positiveness because the negativeness is quite small. So let's pick this one here. We have here plus 2 minus 5. So if I put the plus 2 on this side and put the minus 5 on here, let's have a look what that gives us. So that gives us 2p squared. That gives plus 4p and a minus 5p, giving us a net of minus p. And the last part will give you minus 10. In this type of question here, you've got a bit of trial improvement, so you've got to find the right factor pair and then put it into the right place in order for you to get the right answer. So you go there, factorize, and that one's factorized, that one's done. Okay. Number 20, the diagram shows a ladder leaning against a vertical wall. So here we have the ladder, 6 meters long. It's at an angle y to the floor. It's 2.25 meters away from the wall. That's the wall here. The ladder stands on the horizontal ground. The length of the ladder is 6 meters. The bottom is that, know that. The ladder is safe to use when y is about 75. So we've got to work out what this angle is and if it's about 75. So let's start with this triangle here. As you notice, first of all, this is a right angle triangle. So for a right angle triangle, we can use sine, cos and tan. Okay, trigonometry. So first of all, let's start at the right angle. Opposite to right angle, I always teach my students, opposite right angle is always hypotenuse. Opposite the angle that you're interested in is called the opposite. So that's a bit of a no-brainer, that one is. Opposite the angle is the opposite. And the remaining side, which is the bottom, that is called the adjacent. So the adjacent always gets labelled last, so that's what's left over. Hypotenuse is always opposite the right angle. Okay, and then opposite angle you want is the opposite. Now that we've labelled the triangle properly, we have to look at what identity we're going to use with this sine, cos or tan. So now we have to work at the angle, and we know, we know the adjacent and the hypotenuse. So for any of you who've done Sakatawa, just look at the quick way. So twice the way we use to help us do the question is between A and H, which is A, which is the cos. There's your A. So we know the A and we know the H, but we don't know the angle. So we can use the cos identity. So cat looks like this. That's the formula triangle that we use for cat. So we have so, cat, toa. We will do all three triangles. Right. So what do we know? We know the adjacent and the hypotenuse, and we need to work out this angle here. So I'm going to put a cross there because that's what we need to work out. So you have 2 ticks on the cross. As long as we've got 2 ticks on the cross, that's the one that we use. So this is the right identity for us. Now, what we need to do now, this method uses your thumb. You cover what you want to work out. So I want to work out the cos of the angle. I'm going to actually use my hand to cover it because I've done a large version of it. So the cos, if I want to work at the side, I cover it up. That tells me it's going to be the adjacent divided by the hypotenuse. So let's write that down. So the cos of the angle is equal to the adjacent divided by the hypotenuse. Okay. Now, I don't want the cos of the angle. I want just the angle, which is y. That's this one here. I could really replace this with y. Okay, and this part here is also with y as well. That's the angle that we're looking at. Now, so let's go with this cos. So the opposite of cos is inverse cos. Alright, so let's have a look at some of the values that we put there. So this is now calculator territory. So let's put the values in there. So we say y is equal to cos to the minus 1 or inverse cos of A over H. The A is 2.25 and the H is 6. So we've got to put this into our calculators. So we do here, we press shift and then the cos button, and then we press the, okay, we've got brackets started, we press the fraction button on this calculator, and then we press 2.25 and then press replay, means wrong, type in the 6, and then replay, close the bracket. So now what I've got in here looks exactly like what I've got over here. Press equal, and that gives us an angle of 67.97. Okay, right. So the angle that we got 67.97 blah 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 degrees, and it's only safe which is about 75. So is the ladder safe? And the answer is no. So we say no, the ladder is unsafe. No, the ladder is not safe. Okay, as the angle is not close to 65. 67 degrees is not close to 75 degrees. So no, the ladder is not safe as it is not close to 75 degrees. Number 21. In Holborn School there are 460 students key stage 3, 320 in 4, 165 in 5. Nimmer is carrying out a survey. He needs a sample of 100 students stratified by key stage. Work out the number of students for key stage 3 there should be in the sample. So, number in key stage 3 is that one. So first of all we start with the sample that you're looking at. So it's the selected sample. And we divide that by the total sample size. And then we multiply that by the stratified sample. Okay. Alright, so that's our basic rule for working on stratified sampling. Now let's start putting some values into this equation. So the selected sample is going to be, we need to work out the key stage 3, which is 4. That's our selected sample, 460. So that goes on top. The total sample size is all of these added together, so there's 460 out of the lot. So on the bottom I'm put 460 plus 320 plus 165, and then we're going to times that by the stratified sample size, which is going to be 100. Now that we've got all the numbers in the right place, what we need to do now is put the stuff in the calculator. So we start off with the fraction button and put the top 460, replay, bring the cursor down to the bottom, type in 460, add 320, add 165, replay back up, that brings the cursor back over here, time 100. So now this, what we see here is exactly what I can see in my calculator, plus equal, and that gives us 48.67. 48.67. Now, give you a bit of an examiner's tip here. Normally, students will round this off to the same corner, 46.67 people. So we have 49 would normally be the answer. Is how many people you can pick from key stage 3. But 48 is also an acceptable answer for this type of question. We can also round it down as well, even though it's more than halfway. So in the mark scheme for this type of question, 49 is the answer, but 48 is also a perfectly acceptable answer as well. Okay, let's move on to the next question. 22. H is inversely proportional to the square root of R. H is inversely proportional to the square root of R. Okay. When R is 5, H is 3.4, so that's the stated facts. Find the value of H when R is equal to 8. H is inverse, the inverse part's over here, 1 over. That's a proportionality sum. So H is inversely proportional to R squared. That's how we write it. Now, we need to change it from this kind of, this general form into a form that we can solve. So we say now H is equal to, we turn the proportionality sum into K. Well, K times by 1 basically becomes K. Okay, so H is inversely, means 1 over, proportional to R squared. So that's the K constant of proportionality that we need to work out. So that sentence there gets changed into this. I call this my general statement. Now we've been given an R and an H value. So we've been given an R value and an H value, so we can work out the constant of proportionality, and then we can go and work out the question set here. So let's do that first. So let's have a look. If R is equal to 5, H is equal to 3.4, so we have 3.4 is equal to K over R squared. Alright, now if you want to work out the value of K, K has been divided by 5 squared, so opposite divided by 5 squared is times by 5 squared. So now we have here 5 squared times by 3.4 equals K. So again, calculated activity. So we do 5 squared times by 3.4, that gives us 85. Okay, now once we got the value of K is 85, we can put that value back into K and make this general rule into a specific rule. So this is general, now we do the specific for this question. So H stays as H. K becomes the K value we just worked out. And then the R squared stays as R squared. Okay, so now what we have here is the actual proper rule that we can use to work out the value of H when R is 8. So now after doing all this work here, we are now in the position that we can actually do the question. Then, let's let's put the values in there, let's get started. Okay, so we have h is equal to 85 divided by r squared, which is 8 squared. Okay, which will give you, let's have a look on the calculator, 1.328. Okay, now we can round this off to 2 decimal places. Last digit. This is our decider. So we're going to stop here because that's the last digit. The next one is the one we're going to look at. If it's 5 or more, we add 1. So the final answer will be 1.33 is the height. Now we don't put a unit on here because they haven't given us any units here either. Okay folks, question number 23. Dan does an experiment to find the value of pi. He measures the circumference and diameter of a circle. He measures the circumference C as 170 to the nearest millimeter. He measures the diameter D as 54 mm to the nearest millimeter. Dan uses this formula, pi equals C over D, to find the value of pi. Calculate the upper bound and the lower bound for Dan's value of pi. Now, so pi and the upper bound. So to get the maximum value of pi, what we need to do, we need to make C is the upper value, the maximum value. Okay, we'll use upper here as well. Okay, and we're going to make sure D is the lower bound value. So the way we think about this, if I want to get a maximum answer for in a division question, you make the top number as big as possible, make the bottom number as small as possible, and that will give you the maximum possible answer here. Similarly, let's change color here. If I want to work out the pi, and I want to look at the lower one, the smallest value pi could be. So we look at that C value, we make the C value as small as possible, lower value. And we make the D value as high as possible. Okay, so we're looking at that situation now. If you've got a division situation and you want to make this number as small as possible, you start with a small number and divide it by as big number as possible, and that will give you small values now. Okay, alright. So let's look at 170 to the nearest millimeter. So that's 170 to the nearest millimeter means it's half a millimeter out each way. So that's 170.5 or 169.5. So what we have here is the C value. So this is the C value upper and this is the C value lower. So that's the maximum the C value could have been up to that, and that's the minimum C value could have been in order for it to be rounded to 170. Now let's similarly do another one of these for the D value. So we do over here. So we have 54 is what was given. That's 155 millimeters, 53. And again, it's been told to the nearest millimeter. So that means this here is 1 millimeter. Half millimeter this way, half millimeter this way. So the upper bound here will be 54.5 and the lower bound will be 53.5. So that would be the diameter upper and that's the diameter lower. So now that we've got all the correct values here, we can grab these values and throw them into here. That's what we're going to do now. So, pi upper is C upper. C upper is 170.5. And we divide it by D lower. It's 53.5. Okay, and that gives the value here. We'll do that in a second. Pi lower is going to be C lower, which is 169.5 divided by D upper, which is 54.5. Okay, it's time to jump up. 5 equals 3.1869. Okay, the next one is going to be 169.5 divided by 54.5 is equal to 3.110. So what we need to do first of all, folks, quickly just round it off to 2 decimal places for good measure. So 1, 2, stop down here. So if this number is 5 or more, you add 1, so this becomes 3.19. Okay, this one here, same 2 decimal places, 1, 2, stop there. Look at the next digits, less than 5, leave it alone. There you go. That's going to be the pi, lower one. That's going to be the pi, upper one. And then we need two answers for that. What we do, we go to the front of the paper. We have an area formula which is half AB sine C. Now, amazingly, this particular diagram has been labelled in the correct way. C in the diagram is referring to the angle you've got, and A and B are the sides, either side of it. So this diagram has been perfectly labelled, all the letters of all. This is big C, this is big B, so that makes this little b, that's big A, so that makes that its corresponding length A. So what we need to do now, we need to get these values and throw them into here to work out the area. So it's half times by the A value, which is 7, times by the B value, which is 6, times by the sine of the angle, which is 60. So this formula here, folks, you'll find it on the first page, the inside of the first page of the examination. The formula gives you for the area of non-right angle triangles. So that gives us that. So what we need to do now is work that out. So 0.5 times by 7 times by 6 times by the sin of 60 close brackets, and that gives us an answer of 18.18. Significant figure, second significant figure, third significant figure. So that's still the last digit, and that's the decider. In this case, 1 dp and 3 sf are equivalent to each other. But yes, 1, 2, 3, 3 sf. Okay, that work out the length of side AB, give your answer correct to 3 significant figures. So let's go back to this diagram over here now. Okay, so we're dealing with the same triangle as part A. So we work to the area first. Now we're going to work out this missing length here. Or this length here. Okay, which there you go. Now, whenever we have an angle here in a non-right angle triangle, and we know the side on the left and the side on the right, so we know the adjacent sides to it. So there's the angle in the middle of two sides that we know. We always use the cosine rule to work out the opposite side. So for that we say a squared is equal to b squared plus c squared minus 2bc cos A. Okay. Now in this particular instance, what we're going to do, I'm just going to relabel some of the sides so it matches our rule over here. So this cos A is talking about this angle here. So I'm just going to get rid of this one. So call that A. So that would be little a. Now, B can stay there. And this one is get rid of this one for the moment. C, little c. Okay, it's important that our sketch or our diagram matches the formulas so everything's in the right place. Otherwise there can be some confusion. You put the numbers or letters in the wrong place in the formula and you make mistakes in that sense. So this way it ensures that we get the form, we get all the values going here in the correct place. Don't worry about doing this in examination, that's not a problem. What they want you to do is work out that. So as long as you say at the end, yes, A, B is equal to this, it doesn't matter how you label your diagram. That's irrelevant. So let's go, without any further delay. So we have here, A is this side over here. Now I don't want to work out A squared for myself, I want to work out A. So we need to get rid of the squared, that goes over and becomes a square root. So A is equal to B squared plus C squared minus 2BC cos of the angle A. And we are going to put a nice big square root on it. And that's the formula we're going to use. So we are changing or modifying the cosine rule by a small move the square over to make square root to get A on its own. This A is equivalent to the AB in the question. Now what we need to do is throw in the values. Now B is just 6, the C is just 7, and the A is the 16. We got all the values that we need, just chuck them in. So B squared is 6 squared, add c squared is 7 squared, minus 2 times by 6 times by 7 times by the cos of 60 degrees. And we're going to have a nice big juicy square root sign here. Replace a by ab, that's what we want to look at. Grab your calculators, and just type that in, put the square root sign in first, and just type in everything that you see here as you see. 6 squared, add 7 squared, minus 2 times by 6 times by 7 times by cos of 60, close the brackets there, press equal, that gives me root 43, which is 6.55, 7, so 6.557, blah blah blah. And the question says round up. We want to need that also to 3 significant figures. So first, second, third, last digit, decider. So if you look at this number here, if it's 5 or more, we add 1. So it becomes 6.56. AB is equal to 6.56 centimeters. And that's the end of that one. Okay folks, I hope this has helped. If you want to find out more of these type of questions, please go to my other videos on YouTube, which is talking about cosine rule, the whole exercise on cosine rule. Okay, right. Let's run the simultaneous equations. X squared plus y squared equals 9. This is a circle equation. X squared plus y squared equals r squared. And x plus y equals 2 is become a linear equation. Okay, give your answers correct to 2 decimal places. I'm just going to move it up a bit, trying to get a bit more. Okay, that's a bit too high there. Okay, let's see how we do this question. This question, most students come to this type of question and they get lost and they start struggling. Now, clue in this question how you do it. 2 decimal places. Give your answer to correct 2 decimal places. That means when you get to your factorizing part, you're going to need to use a quadratic equation, and you need to be very careful how we do that in the calculator. I have some videos on that as well, so if you want to see how we use the calculator properly. Now let's get started. Okay, I'm going to call this equation equation 1, equation 2. Now, unlike your standard linear simultaneous equations, linear and linear, where we eliminate one of the x coefficient or y coefficient, this is one we can use the method of substitution to eliminate. So what I'm going to do here, I've got x squared plus y squared, so in terms of x and y, I'm going to eliminate y by substituting y from here into there. So let's rearrange the bottom equation. So if I want to make a y the subject in the bottom equation, I'm going to get the plus x, take it over, and it becomes a minus x. Now what we can do now, we can say, now that we know that y is equal to this, we can get this part here and substitute it into there. So now we have, if you look over here, x squared and y squared is equal to 9. Okay, we just worked out that the y is equal to 2 minus x. So y squared means 2 minus x squared. Copy down the x squared. Hasn't changed. So that's the first step. So we rearrange the linear equation and make y the subject and substitute it for y. So now what was originally x squared plus y squared, 2 unknowns, we can't do anything about it, has now become nicely x squared and then more terms in terms of x. So we should be able to multiply this bracket out, simplify it, rearrange it, get a quadratic equation and solve it. Let's see how we do that. Now, 2 minus x squared does not mean 2 squared take x squared. Please don't do that. That's a common mistake made by students in examinations. Do not do that. This means, the squared means this bracket times by itself. So we have here now x squared, let's copy down, plus 2 minus x times by 2 minus x is equal to 9. So let's do like that. Okay, let's get purple. Colors are going for the flying guys on. So let's multiply the brackets. So 2 times by 2 will give us 4. 2 times by minus x will give us minus 2x. Minus x times by 2 will give you minus 2x. minus x times by minus x will give you plus x squared. Okay, now what we need to do first of all now, let's get the number 9 onto this side as well, so we can simplify it all and get a nice lovely quadratic equation. Because we got all the ingredients for quadratic equation. We've got x squared terms, we've got x terms, we've got numerical terms as well. Let's get this numerical term on this side. What I'm going to do, a little cheat here. We can get the 9 from the right hand side, throw it over here, it becomes a minus 9, so there we go, minus 9. And we're left with the equal note on the right hand side. So let's start simplifying this. I'm missing a particular colour. Okay, let's have a look. So we have x squared and x squared, adding like terms. That gives us 2x squared. We have minus 2x and minus 2x. That gives you minus 4x. Okay? And then we have plus 4 and minus 9. That gives you minus 5. Okay. Now, this is our quadratic equation. I'm not even going to try to factorize it using the 2 brackets technique, because it'll give you answer correct to 2 decimal places. So it's going to be something that needs a calculator to be used in this particular instance. If they didn't mention this, then I could straight away jump on the factorizing technique. But that indicates go straight to the formula. So let's write down the formula for the quadratic equation. That is also available on the front. Okay, on the front inside page of the examination, right at the bottom of here, quadratic equation. So we say here, x is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. Okay, so that's your formula for the quadratic equation. Now we need to correspond these b's and a's and c's to an hourly. So we have 2x squared, right, so that becomes ax squared plus bx plus c is equal to y. That's your standard quadratic equation format. So now we can quite easily pick off the a and the b and the c value. So a is over here, b is over here, and c is over here. Now one thing that students get a bit confused by, it says plus b and plus c, but I got a minus a and a minus a. That's like saying a squared and the b value, x, and the c value. So don't say the plus here and get confused, oh well, she's going to be plus and minus, it means and the c, but the c here is negative, and the b here is negative, so that's not a problem. So let's write down those values just to kind of emphasize them. So we write them over here. A is equal to 2, b is equal to minus 4, and c is equal to minus 5 from here. So these A, B and C values are all literally hand-picked from here by looking at the template, and we've got our values A, B, C. Okay, let's put the values in. Alright. Minus B. But B is already minus. When you apply a minus to a minus quantity, it becomes positive. So that just becomes plus 4. Put the plus there for emphasis. Okay? So then it's plus or minus. I'll show you what we deal with this in a bit. And then we have b squared, so minus 4 squared. Take away 4 times by the a value is 2, times by the c value is minus 5, put a little bracket in there, and minus 5. Okay, divided by 2a, a is 2 times by 2. Now, if the students can get up to here, this is the part where many more mistakes are made in terms of how you enter this into your calculator in one go, without keep stopping and starting and making sure that you use the little baby minus and the big takeaway here and the little baby minus here as well. So again, if you want any more assistance on that, please refer back to my quadratic equations video, and that shows you the calculator, but I'll try my best to explain to you what's going on. So plus 4, we don't need to do anything for that, but we need to put the square roots, we need to put the fraction button in first. Fraction which sets up the fraction. Just type in 4 for that one, and plus for the moment, we're going to do one at a time. We can't do plus and minus in the calculator in one go. We have to do the plus variation, then the minus. Plus, and then the square root sign, this one here. And this minus 4 squared, as you see there, bracket, little baby minus, and then 4, close the bracket, and then the squared. So as we see, put it in. Take away 4 times by 2, 4 times by 2 multiplied by, now you got minus 5 in there, so bracket and the little baby minus, okay, 5, close the brackets, press replay to bring the cursor to the bottom. So it should be at the bottom now. Okay, so go to the bottom. 2 down by 2, I have to press it twice. And then 2 down by 2 in the bottom. And that should give us an answer of 2 plus root 14 over 2, which is 2.8. So we actually with two decimal places. So we say x is equal to 2.8708 blah blah blah. Now, we've got to round off to 2 decimal places. I'll make sure the video is okay. So, pardon me, 1, 2. First decimal place, second decimal place, boom, 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 boom. Last digit. And this one is the decider. Look at this number, if it's 5 or more, we add 1, but it's less than 5. So we just leave that part alone. So it becomes x is equal to 2.87 to 2 decimal place is one answer. And here comes the variation. Now, as we said to you before, in the calculation we had a plus and a minus. We got to go back and use replay to bring the cursor back, use the same calculation and change that plus into minus. So here we go. So here's all my calculations top of there. I'm going to press replay now. And it brings the cursor back, brings the question. I'll do that again. It's gone at the bottom, press up, it's gone to the top. Keep on pressing to the left, replay. And it's going to take a few more seconds. There we go. I've got to the plus. So I've got it back to the plus, and I'm going to delete it and put the minus in there. Okay, so now in the next calculation, I have, okay, way around. I've got rid of the plus that was in my calculator and put a minus there instead. That's all. Okay, now we press equal again without having to type it all over again, and that gives us an answer of, okay, minus 0.8708. Okay, let's get the red. We nearly finished the paper. Minus 0.8708 blah 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 blah. Okay, we need to round this answer to 2 places. So 1, 2. Last digit decider. That's less than 5, leave everything alone. So my final answer is so there we go. At the moment, what's that? We're given us is two x values. Okay, we need to forget. We've got 2 x values. We've got to go and work out the 2 corresponding y values, because like a normal simultaneous equation, you have an x value and its y value. But here we've got 2 x values, so we'll have 2 y values in the answer, and that's all due to that square bit that there. So let's look at the corresponding y values now. Let's change color. To work out the y value for this, y is 2 minus x. So y is equal to 2 minus the x value. So y is equal to 2 minus this, 2.87 blah blah blah. Same for this one, y is equal to 2 minus x. Where did we get this from? There it is. Y is equal to 2 minus 0.87. So 2 minus 0.87 will give us an answer of y is equal to, well, that becomes a plus. So 2 add 0.87, so that gives you 2.87 for its corresponding y value. And this one we're going to have 2 take away 2.87. So that will give you, so 2 take away 2.87 will give you minus 0.87. That will be deficit. So you only have 2, and you've got to give more than 2 away, so that will be the bit that you owe. So that should give us our corresponding values. So just to quickly circle them, here's my first x value and its corresponding y value. Here's my second x value and here's its corresponding y value. So the solutions to this simultaneous equation, this and this, is x equals 2.87 and y 0.87 to 2tp, or x is minus 0.87 and y is equal to 2.87. Okay, folks, I hope this question, this techniques has helped you with your examinations. This is the end of the paper.